if you're an operator or managing that facility and you're only used to seeing this screen in front of you and what's going on out in that feed mill, two things. If there's somebody out there who's been in that feed mill with you, that's been there for 30 years or 25 years plus, go ask them questions. Just say, hey, inquire about X, Y, and Z, and walk the feed mill. You have to walk the feed mill no matter what. You can't just sit on the computer and hope the reds and greens and flashing are doing it the right way. You have to understand it.
Welcome to the Feed Science Podcast brought to you by Wisenetics. I am Carlos Campabadal from Kansas State University, dedicated to bring you the latest insights and discussions in the feed science industry. Please get ready to expand your knowledge and stay ahead with today's episode. So welcome everybody to our podcast. Today we have a good friend of mine and a collaborator here at Kansas State University, adjunct faculty, Dr. Patrick Clark. We're very happy to have you here today at the Feed Science Podcast. And I know this is your second one, but we're covering a different, very important topic today on optimizing batching and mixing in the feed industry. So with that, welcome, Dr. Clark. And if you could kind of, for our audience, introduce yourself. Some might know you, some might not, but it's always good to remind the audience on it.
Thank you, Carlos, for having me, and thank you for all the listeners and webcast audience out there tuning in to listen to us, taking the time out of their busy day and busy schedules to maybe catch a couple quick points to help them out, maybe increase some efficiency and quality, et cetera. And so, like Carlos, you mentioned, worked adjunct appointment at Kansas State University, and you and I are coming around almost 15 years of collaboration, working through the Department of Grain Science and IGP, working with industry partners out there and helping advance a little bit at a time, everyone in the feed industry. So once again, thanks for having me, and we'll talk about, like I said, batching and mixing, and I'm sure all your audience at the end will know and have all of our contact information to reach out, and that's what we're here to do, help everyone out there and get a little better and solve a few points if they have to, because we look in the U.S. Over 5,000 feed mills or out there, and so each one's different. But one thing that has a common denominator is every feed mill, whatever that may be, has a mixer, some type, or they do some sort of mixing and some sort of batching, even if it's only 2 ingredients to something as complex formulas that have 100 ingredients. And so it's pretty critical for those feed mills and et cetera out there, not only in the U.S., but worldwide, that everyone has one out there.
And again, thank you very much for joining us. I mean, I think this is a very important topic overall. As you said, every feed mill has some sort of batching and definitely mixing, either just a feed mixer made either vertical, horizontal, even just a concrete mixer. It's all at the same time, the importance of getting those ingredients to be able to be in all that batch, so the animals get all those nutrients and ingredients. So we're and that's very important. So I think today it will be a very good day to kind of pretty much guide everybody on technical aspects of overall thinking about how to improve your batching, and especially I think mixing, and most important, how to know if you're doing a good job on mixing. And first of all, of course, for our audience out there, both domestic and international, please comment if you have any questions. And as Patrick said, our contact information is there. He will be very happy, and the rest of us to be able to answer any questions with that. So with that, let's start with batching. So just tell us a little bit on your concepts, on your thinking. What are the key things to involve into having an optimal batching system first, of course, and then we'll move through the mixing?
The first question we all of us will get is, how do we go faster? How can we make more feed faster?
Yeah.
And not cost me anything, right? We don't want to put any major improvements in that facility. What can we do? And I'll look at it from the standpoint when I walk into that feed mill, if somebody calls and says, can you come help me? In a general broad sense, as a general rule, now we're here 21st century. We are 75, 80%, 85% automated at some point. And automation has been around for 30, 40 years, some form of automation, whether it be primitive standpoints, when we had the push button type automation, to now fully lights out, don't almost have to have an operator or anybody on site type technology is there. The common denominator, that two things that are there, are the operators or the people, that can have inherent error. And then that computer system is there and has been there. What has been changed, whether it be intentionally, accidentally, the first question I ask when I go in is, why are we doing it this way? And the inevitable answer I get is, I don't know. We've always done it that way. And so right. As the managers, the supervisors, the leads at that feed mill, take that few minutes to go out, walk, and ask why they're doing it, and look what's going on. Automation is nothing but a bunch of ones and zeros. And when that program or that computer system, if we walk into many feed mills, those are 10 years old, 15, maybe 20-year-old automation programs. And when they have it, there's timers set in there, whether it be, in an automation package or computer package, all it's seeing is a signal, right? It doesn't know if that's corn in the bin or lysine in the bin. It's just assuming that someone has put that incorrectly. And so, the computer's only as smart as the operator that puts it in. And so when we go in, we want to look at the timing. I look at timings with regards to gate openings and gate closings. Is that system cleaning out effectively or efficiently as it's supposed to? Or did we have some formula changes along the way? Inevitably we've had, but are there major enough formula changes that the mixer gate stays open for 10 extra seconds, or the scale discharge stays open for 10 extra seconds from a timing standpoint? But most inevitably, and recently we had a short course at K-State, and we have annually have our short courses. When I go and I discuss with operations management supervisors, batching and mixing has that inherent, what's that big red button? The accept button, right? And what do we do when that operator is continuously hitting accept? We get those printouts or those digital things every day, every shift, every week. Are we actually reading those and actually doing something with them? Or are we just letting those guys hit accept, accept, accept? I know we're not going to go climb into that scale and dig out 10 extra pounds of salt or 100 extra pounds of corn. I know that's not going to happen. But if it's a consistent problem, that alarm in there time and time again, that throws off our books or with regards to our inventories time and time and time again. And it also costs time and time and time again. And so, those small things that we get involved with, the humans get involved with, we have to deal with it. Don't just, I know we're fighting all of our things, right? Our EPAs, our FDAs, our DOT regulations, all of those things. But this is one of those things that helps in the forefront. It helps accounting, efficiency, et cetera. And so it's critical for us to look at that.
One thing that you mentioned that pops in my mind is that I know we're talking about batching system, but overall applies for all the feed industry and everything. Right now we're in the world of big data. I mean, data collection, and it's just like you said, not getting like the printout. Is what do you do with that information? And I think that's what I have seen, and you and I have been involved in many visits in feed mills all over the world. But a lot of people don't take the time to read the data analyze it and make decisions based on that. I mean, like you said, you hit accept, and then you realize there may be something wrong in the system, or something not calibrated, or something not closing well, a valve, a gate, whatever the case is. So that's something to, I think, for our audience to always think about it. That's where we have to move if we want to make our industry overall better. I mean, it doesn't matter if you're automized, if you're semi-automized, or whatever the case is. Understanding data to make technical informed decision is key on that. So also for our audience, if share the video, please. If you learned something new today, we like to always see how our audience can interact with the rest of the public there. So based on all what you say, what do you think it is kind of like the trend going on in terms of how can we make those batching systems avoiding that human error? I mean, we have some, like you said, it's a lot of ones and zeros over on the automation, but I'm trying to go more into what new technologies, sensors, things like that, that simple things that can maybe improve somebody's feed processing.
And I think in one of my previous, and I think some other of the presenters out there is looking at the maintenance, is being on top of that, because the focus is we're making feed for those animals, those protein sources, whether it be a 1,000-pound steer, or a 100-gram chick, or a few gram shrimp, or whatever that may be. We are making a quality product, and so we have to do it safely, because when an FDA regulator comes in, that's what they're looking at. And so they're coming in to make sure we don't contaminate feed. And so with that technology, we've got that proof there that we're doing, we're proving what we say we're doing. And so not just having that accept button all the time is using that data to fine tune everything. Because once again, I kind of joke, we have, there's a lot of fabulous nutritionists out there, and they're going and they're driving the protein. What are we formulating for on a typical corn soy diet in the monogastric realm, with a whole balance of amino acids? And that's what we're doing. We're getting a lot of more or increased buying power, or we're focusing our buying power, because we're not making huge margins. It's a very thin competitive market. So we're buying synthetic amino acids individually. We're getting enzyme packages, multiple enzyme packages, vitamins, minerals independently. And so when we have this multitude, and the nutritionist formulates the diet to 1.7345, and that's input into we've got scales that, we're using scales that aren't even that sensitive. And so that's where I think we'll get to moving to is incorporating higher. The scales technology is getting better. And so we're going to be moving to more sensitive scales, or the cost affordability when we build new plants. That scale can be a little more sensitive and react quicker than what we have. Most everybody that we've been in, and those operators know that when we're filling that scale, it has a residence time that scale is calibrating or trying to catch where we're at. And so that's getting better, on top of just fine tuning how fast we can hit those critical points for that animal, whatever that our target protein source is. So the sensitivity to the scales, I believe, is going to be getting better, on top of the speed that we can formulate and get that in the scale is going to be critical, on top of the data that we have to analyze of that. I think at some point nutritionists, I know they want to, but once again, we've talked about quality control. What do we do? What does that operator do? We go out and we're grabbing some samples. We've made a batch of feed, and we're grabbing a batch for our medicated feed requirements, FDA regulations, or maybe we got a new enzyme or whatever. And we grab those samples on Monday. Well, Monday we grab them, we ship them off, they get there maybe Tuesday they're analyzed, or Wednesday they're analyzed, and we get the data back on Thursday, and we're feeding a day 0 to 7 starter of poultry. Well, that animal, we've already changed to the grower. We're thinking about already changing to the grower because it's already in the bin for the one load. Or we do it on the flip side. We're on the tail end of a finisher, of whatever that may be.
That's right.
What good does that do us? That animal has already consumed half of that. So I believe and feel that that's where we're going to be in the future, or it's something definitely be thinking of, is tying NIR data into active modulation. So we can, when that load of corn comes in and the nutritionist has based it on 8% crude protein, and it's 8.3, 8.4, 8.5, well, he can back off that soybean meal, for example, or he can adjust his amino acids if he's in that area. And so we can really fine tune that it's almost a continuous type batching situation to help. Once again, economics is driving it.
And I was just came back from doing a training abroad, and participants from several countries from Latin America, and that was a big thing. People saying, hey, for example, some of the bigger feed companies saying, hey, we have invested in inline NIR for the feed ingredients, to adjust what's going into the mixer. But some people are saying, hey, I want to do it even after mixing, just to see how my feed is, and readjusting, which goes what you said, the offset of, maybe it's too late, because already all the runs of those batches have been done, or maybe so it's also a cycle thing. But I think the idea is out there. Of course, I know some of the NR equipments are really working on that, and some other industries like the flour industry has had those inline NIR for quite a while now. But I think that's where we have to go when we want to really optimize. As you said, and coming from the feed industry before my academic role, the margins are very little. So you have to really fine tune in order to make a difference and try to get some gain for the company.
Correct.
So with that brings a lot of that. We talk about NIR, and I think there's a big thing into it. What's your feel? Well, let's jump into mixing now, and then we'll talk about NIR after mixing, because I think that opens a lot of doors, and I think the audience will do that. And by the way, of course, for our audience out there, subscribe to our channel, click on the bell to receive our notifications when new things come, new podcasts from all the different areas that we have. So based on that, we talk about batching and new technologies and how you optimize in automation. Let's talk about mixing, because like you said, I believe sometimes it's just the heart of the overall feed manufacturing process, because every type of feed you make, you have to mix ingredients on that sense. So how can you tell the audience what is your key point that you think anybody should be looking into, how to automate your overall mixing and check for efficiency?
When we look at mixing, the questions they'll say, people are thinking about maybe building a new plant, or their mixer is old and tired and they want to replace it. And they go, what's the best mixer? Mm-hmm. And then they say, what's the best CV? what should my CV be, or something to that effect? And as of now, we as an industry have assumed or taken in that a CV, coefficient of variation, of 10% or less is acceptable. And then, but many people are pushing to 5% or less on the mixer CV. A couple points. There is some to little data out there that 5% less CV is good for everything. And so it's something to consider. Does that 1,000-pound steer need a CV of 5% or less for that animal, or that few, 100-gram chick need a CV of 5% or less? Maybe, but there's minimal data out there to support it. We've assumed it. And so I guess my point is to challenge it and push the envelope a little bit is if you have a mixer CV of 6%, why? Mm-hmm. Can you get away with an 8% mixer CV? I can't answer that, and I don't want to answer that, but I'm going to say I would say yes in the literature, and we're still below 10. And so if 5%'s great, but 8's okay, why don't we speed up that mixing and batching process to gain us 5 seconds or 10 seconds in the process? Because in feed milling, it's a snowball effect, or it's death by 1,000 cuts. But 5 or 10 seconds per batch. If many of you out there are listeners, your systems are running 12 or 24 hours a day, or however your shifts operate, but you're in the 10 batches per hour, 11 batches per hour, something in that window. And so if you have a 5-ton mixer as on average, and you can find 10 or 15 seconds batching, you still, going from a 5% CV to an 8% CV, those animals are still going to do fine. 15 seconds on a 5-ton mixer will gain you approximately, even if I'm theoretically taking out and theoretically doing it, a 6,000, 6,500 ton a week, we can gain 10%, 500 tons a week. There's not an operator out there or a feed facility out there that wouldn't turn down 500 tons extra produced a week by doing nothing, by checking, once again, checking our timers, coming full circle around everything. We have a good uniform mix, less than 10%.
Exactly.
And our animals are doing well. And we haven't done anything. We haven't had to invest mechanically, et cetera, in that process. And so, even if I'm half wrong, any feed mill would be happy to take 250 to 300 tons a week, 10 semi-loads, if I'm half wrong.
Yeah.
And it costs them nothing, but just going out, checking, going through the process and seeing how to get, make more feed and still doing it safely.
Or even just cutting the times that your workers have to stay. I mean, at the end of the day, maybe.
Absolutely.
So you also have to think about, for those that meet a quota and that's it, you save time, and especially with the labor shortages that we have, it's just on that. So, and I think that's very important. So based on that, you raise a question that a lot of people say, okay, CV, coefficient of variance. And I do believe there's, and I know you did your research on your PhD some years ago based on that part of it, but tell us what you think of all the different CV tests that are there, which one you will recommend somebody, and then we'll go from that. Because what I wanted to get to the point is, when you measure a CV, you usually put in some sort of ingredient or something that you could pull out and measure it and calculate statistically that coefficient of variance. But
yeah,
you're doing it on the dry mixing cycle.
Yeah.
And how do you correlate that with your wet mixing cycle on your overall batching? I mean, your overall mixing time. So let's start on that, on the different tests and which ones you think is more appropriate and all that type of things.
There is some old adage out there that maybe we could use, because I'll use the word loosely, when cheap, right? We want to do it something affordable and quick. And crude protein had been out there for a while. And crude protein, I want to squash that now. I hope, and if you are using crude protein as a marker, I would strongly suggest looking at different options. As an example, or to illustrate that, I can fill a mixer 50-50 with a meat meal and soybean meal, not turn one revolution of that mixer, probe it or collect those samples. And my CV is like 2.1
Mm-hmm.
if we just use some standard values. And I didn't turn the revolution of that mixer one turn. And so the problem is we're capturing, and when we're analyzing that product or that material, we're basically looking for the nitrogen aspect of it. And so that doesn't give us a good response of what we want to achieve. And so what we're seeing and what we've suggested and looked at is an industrial amino acid, a D-L-methionine or a lysine, has its own unique characteristics. The whoever your supplier is, there's suppliers out there for your amino acids, lysine, methionine, a threonine. Those suppliers look at that marker, and it's 100% unique to it. It's not picking up something else or another item out there, and so it gives a good response to what your mixer is doing. One, and typically the nutritionists out there are starting or formulating against that lysine, methionine, threonines, against it. And so everything floats around that as a general rule. And so if we have those things mixed uniformly, that's going to give the best response to those animals, on the monogastric side, for example. And so it's a good way to go about it. There are some other items out there that are good tracers that are out there that show that show good mix. Those tracers out there also show and help for a good clean out post that mixing. That are we getting a good flush or in our sequencing, and that shows that or proves to any regulators out there that we are doing a good job cleaning that mixer out, which is, besides making a good batch, we are also proving and needing to make a clean batch or a non-adulterated batch of feed also. So
yeah, very important.
So we can get two birds with one stone, as they say.
And what will be your thoughts on a lot of folks out there use the Quantep, of course, measuring salt because of the cost and easiness to be done in your own feed mill.
Yeah, and I think that is a good spot check. It's kind of, and I'll make it analogous to the black light of mycotoxins, right? It's a good spot test to kind of give us and see where we're at. But, quarterly, annually, or however, if you're, whether you're a licensed medicated feed facility and having to do your medicated feed additive checks and validations, that you go and take those industrial amino acids and go send that out to that third party, your supplier, your vendor, whoever, to prove that Quantab is giving you good results and making adjustments if you need to on that.
Okay. And based on that, on the Quantum, of course, MicroTracer is also a very popular one. And I personally didn't like before the MicroTracers when I did it because you have to count spots, and I'm not a good dad and paying attention. But now they have an app, and it's fairly simple now these days. But I also like to tell people, for spot check, what you said, thinking about that, do something that is easy, fast, and reliable that you could be constantly using. But based on that, one thing that I see people sometimes is that, they measure a CV with one, let's say you're measuring amino acids, and then you're doing your Quantep, and then you're using MicroTracers, and they don't really relate, but they get concerned. So can you tell us a little bit about that? I mean, how can you help somebody make a decision based on precision? Don't use several, and if you use them, be aware that they don't come up with the same result because of the different ways and procedures. So a little more into that technical CV type of deal.
Correct. And some of those, and what you said it and you didn't even know you said it. With regards to, you're doing the MicroTracer and you're kind of counting, and you may, maybe your eyes aren't the best, or on the salt, when we do the Quantab, many of the participants at K-State and et cetera, other, short courses, you have a capillary on a stick, a test strip, and maybe your eyes see 6.1 and it's 6.2 or 6.3 or something to that effect.
Yeah.
And that is something to be concerned about, because not only do we have the human error in the process, but we have analytical error. And so when you're looking at those products, medicated feeds have a huge, some people say, let me check it with my medicated feed. Well, some medicated feeds have 30% analytical variability. And so you have a wide range of error just in that sample. And if you're grabbing 10, you could be inconsistent, and you're sitting there looking, why is my data all over the place? Or same thing with your microtracers or others entities, metals or vitamins have huge analytical variability. And that's where also we're coming back to those industrial amino acids. That's very tight, very narrow variability or error that can occur. And that helps on the precision of the decisions of why we use those markers to help us in getting that good data. One thing you also mentioned, that if we're grabbing 10 samples and we're looking at coming back to our accept button, is we get a CV, and it is possible that we grab 10 samples and I'm going to use a location, we grab 10 samples, 1 through 5 and 6 through 10 in our mixer. And we have a CV that's less than 10, and we're like, okay, that's great. They get it from the lab. Well, you can have a CV of less than 10, but 2 of your locations, for example, one's really high and one's really low, that we would refer to as maybe a dead spot.
Mm-hmm.
And so that's something else to take it to once again, just keep following through on everything, is look at the CV. Don't just say you've got a CV of 5.5 or whatever it may be, 7.5, and say that's good. Look and see if you have those 2 dead spots, or as an example, look at the data. If you've got several things that you could have a broken paddle, because generally, unless you have a really, let's say, high molasses type of feed mill that uses a lot of molasses, a lot of fats that are in the mixture, because you're doing a lot of mash diets,
Mm-hmm.
and you're not doing any post-pelleting fat application, you can get buildups. You can break a paddle, in those, or you have a bent ribbon or something like that, and that creates that dead spot. Because most people don't stick their head in and look at the mixer. As a general rule, it's mixing, it's running, and it's getting feed out, sending feed out. And so look at those, read and once again analyze that CV data, and making sure that you have that the numbers actually make sense and look good.
Based on that, also, it always is the concern of a lot of people saying, hey, should I do 2 CVs, one for the dry cycle, and then which will cover the wet, but one just for the wet, to see how let's say you put any type of synthetic amino acid in liquid form or any other product, liquid ingredient. Should you use 2, or what will be your thought on how to optimize that process of quality control?
Yeah. If you are doing a liquid methionine, liquid lysine, some of those, choline chloride as an example, if you're doing those truly, I'd call it nutrient
Mm-hmm.
critical ingredients in a liquid form, I would look at the liquids look at the mix or the CV of those liquids to make sure that is getting put on uniformly correctly, because those liquids are in a small dosage level on a per ton basis. And so it's critical for that, because you have a plugged nozzle or a broken nozzle in those mixers, and you're just globbing, you're streaming in, and everybody, the listeners who are familiar with know what I'm talking about, and you get dough balling and or something to that effect, especially if you're also adding 1% or 2% of fat, that you can get that dough balling effect. That you do that on a starter diet in a poultry facility, you're gonna have featherless chickens as an example, and so it's going to have pretty significant ramifications on that. So yes, I would suggest, like I said, if you're doing a liquid lysine, liquid methionine, something to that, I would definitely look at what that is after the wet mix cycle.
So of course, for our audience there, again, if you have any questions, please leave it there in your comments, and also if you have any suggestion for any new guest or any topic, please also let it there in the comment section. We will definitely address that. So going back on that, on the wet and dry cycle, I know it depends a lot on the mixtures, but you get a lot of people saying, so based on my CVs, I get all confused and say, so how do I determine my dry and wet mixing cycles? What will you recommend, or how do you will tell somebody to look into that?
First and foremost, I'm gonna we'll just I hate to say we're gonna go to the basics, right? So when you most people, the only reason they've looked at a mixer handbook or the blue book that they have is they've had a gearbox or bearing blowout or something to that effect, and they're looking up the part number to know what to call to get it fixed, right? But if you look at that, every mixer that is sold in the world is sold on a volumetric basis. And so we start at the fundamentals. I hate to say that. Start at the fundamentals. Go to that book and see what that mixer was designed for and what it was recommended once it left the factory. And if you're a few percentage points off of that derivation of that, you've got to start back where it was from and where it was originally manufactured for. And then at that point, you can work your way from there to say, hey, do we need to adjust our dry mix cycle or wet mix cycle, and test each, if you're starting from ground, if you're assuming a ground zero starting point, test your dry mix and test your wet mix and go from there. So Dr. Binky, Dr. Herman, in the mid 90s, posted our bulletin that, kind of has a percentage range of, if we're off of our CV, if we're 10 to 15%, increase our mix time.
Yeah.
If we're a little higher, we need to go in and clean, do a few more investigations of what may be happening. If we do a CV and we're 25% or higher, we've got a problem. We've got broken paddles. We've got other issues, et cetera. And so we've got a tired old mixer. And so something is wrong, and you need to call some whether it be the manufacturer or other experts out there to look at that and see what's going on.
It's time for our famous three.
Well, this is great information, and I know we're coming kind of like at the end of our podcast. I think this has been a very informative session, and I'm pretty sure the audience will have more questions or comments. So please leave them there in the comment section, and be sure to that. And of course, for our audience, please visit our site, Wisenetics, and learn more about all the other podcast segments like we have: poultry, swine, dairy, beef, cattle, and of course, pet food beside our Feed Science podcast. So with that, Dr. Clark, as you know this, and we always like to, as we wrap up our sessions, ask what will be your recommendation for the audience, and look for technical information or a book or website, something around those lines, so you can learn more about batching systems, and of course also mixing, or even just literature on CVs, so people can look for their own. And we know that there's information out there, but sometimes it's hard to find. So what will be your recommendation on that?
Well, reach out to yourself, myself. There's K-State, North Carolina state bulletins out there with regarding to proper mixing and fundamental techniques and trainings, and go out and find that book of yours, your manual of your mixer. Just take the few minutes, say, hey, this was that is the heart of it. That's where it was manufactured on and where you have to start from. So, if you've had a mixer that was based on a corn soy diet, and for 4 tons, and now you're making 5-ton batches, you've got some work to do. We've got a problem. Or you had major formula changes and you're bringing in a lot of DDGs and wheat mids, and that bulk density has gone down, thus adjusting everything. So go look and just read it. It's a wealth of information. It might only be 4 or 5 pages, but it'll tell you what that's supposed to be, and what the original intent of that piece of equipment was supposed to be.
And I agree. A lot of people don't even look at them, or somebody will say, like you said at the beginning, that's how we've been doing it, and somebody told me to do it that way. But that's a very good advice. And besides on our topic of batching and mixing, what would you recommend in your favorite book or resource to help understand everything related to feed manufacture or even outside of agriculture per se?
We have the feed manufacturing technology books that are wonderful resources that you can find. Feed manufacturing technology 5, I believe, is where we're at, and I think you can get some of those either digital or paper versions, and that'd be just from quality receiving. If you've got new employees, because once again we mentioned labor's tough. It's not a beautiful industry, as in they say, but it's a noble industry. We're feeding the world, and we've got new. You may find some new great talent that's just not used to agriculture, and so those feed manufacturing technology books are a great resource to help them start getting their arms around it. So
great. No, this is a very good info, and so in your opinion, talking about feed professionals, what could be some good advice to set them apart for those who are not successful, or overall anybody in the agriculture industry? Just kind of like say, hey, for a young audience out there, try to focus on this, look for this other things, kind of to bring a success of professionals.
We are at the point in the feed industry, once again, that we've made some comments with regards to technology, right? We're both, you and I, are having this on a webcast technology type, whereas 20 years ago, we wouldn't have even almost thought of that. And so the youth out there, the professionals, if you're an operator or managing that facility and you're only used to seeing this screen in front of you and what's going on out in that feed mill, two things. If there's somebody out there who's been in that feed mill with you, that's been there for 30 years or 25 years plus, go ask them questions. Just say, hey, inquire about X, Y, and Z, and walk the feed mill. You have to walk the feed mill no matter what. You can't just sit on the computer and hope the reds and greens and flashing are doing it the right way. You have to understand it, because I hate to say sometimes a computer may not always be honest with you, right? And so you've got to understand why that you've lost something, whatever that may be, and figure it out. And so you've got to understand the flow of that process and how it's going.
Great, perfect. No, this is great information, and thank you very much, Patrick. It's always a pleasure, and we definitely appreciate you taking your time and to come and talk about all your technical knowledge there. And for our audience, this concludes another episode of the Feed Science Podcast presented by Wisenetics. Thank you for joining us today. Please don't forget to subscribe to our podcast and stay updated on all of our future episodes. And if you enjoyed today's episode, please leave us a review. This is very important for us because your feedback is very valuable, so we could always improve and look for more topics. Until next time, this is Carlos Campabadal from the Feed Science Podcast signing off.